Hello everybody, my name is Vladan Jevremovic. I will be presenting the Capacity Challenge. A company I work for is IBWave, and what you see here, it says the in-building wireless standard. This is our subtle way to say that we were really good at providing RF planning software. The reason why you may not have heard about us in the past is because we have been focused on cellular side of in-building wireless. But about a year ago, we have launched our IBWave Wi-Fi module, of which I will be talking about a little bit later. But we basically are the in-building cellular RF planning and design standard in North America mostly, although we do have presence elsewhere, mostly in Europe. And the company is headquartered in Canada. I'm based in the US. We do have a worldwide presence in North America mostly, but also in EMEA region and in Southeast Asia. So without further ado, I will be talking about capacity, mostly exclusively today. I'm going to go over the factors affecting capacity dimensioning. Most of you are really good at knowing what they are, but this is kind of a refresher course that I will be going through. Then I'm going to focus on granularity. I'll be talking about how important granularity is in RF propagation, how important it is to take into account the 3D picture, especially in multi-level buildings. Talk about granularity of a user profile for capacity calculation, and capacity zones, how important it is to identify areas on your floor plan where you may have users that can congregate certain parts of the day, like we are doing right now in this area. Later on, we will talk about cellular and Wi-Fi and what's going on there and what's going on at 5 gigahertz and how they may affect the future capacity calculation. And in the end, I will give you an example using our software, how you can calculate the capacity and present the results, and how you can specify your user profiles and what the results really mean. So, to start off, factors affecting capacity dimensioning is the first and foremost is the quality of service of applications that you are running. As you all know, there are 4 QoS types: voice, video, best effort, and background. And as you all know, voice and video are less packet jitter and packet delay tolerant than file transfer. And so because of that, you have to account that for that the fact that you can have fewer customers that are running voice over IP per your AP than you can for, let's say, file transfer, when it is mostly file transfer happening on the AP. So this is kind of a trivial thing, but it has to be reminded because in various areas or your venue, you may have predominantly users that are going to be using voice over IP or predominantly using file transfer. Or you can have a whole venue that is going to be using one type of a QoS than the other. For example, in stadiums, you can barely hear yourself because how loud it is. And in the stadiums, you would mostly count on having file transfers and not voice over IP. The venue type, I just mentioned that based on the venue type, you may have one of those QoS being predominant, or you can have several. For example, in manufacturing, it is mostly voice intensive, so you are really have to pay attention as to how many concurrent clients you're going to have per your AP. In a stadium, it is mostly data intensive, so having a low packet delay is not really of a great concern. But in a hospital, it's very challenging because there you're going to have voice and data and real-time location. So 3 of those that you have to pay attention to. And each of those venues have a separate profile type. We will be talking about those later on when I'm going to show you an example how it's done in our tool, when we have actually pre-signed for various various venues user profiles. Then the next one is your UEs. Does your UE have 1, 2, or 3 streams? And this is really not about the size of the RF circuitry that is going to be put in your UE. It is more about power consumption. So that's why your smartphone mostly has 1 stream, and your tablets have 2 streams, and your laptops have 3 streams because of the power consumption. So what does it mean? Well, if you have your 3x3 MIMO AP, that's all good and nice, but what happens if this room is full of smartphones? That means that I'm not going to be able to get that advertised 3x3 3-stream MIMO data rate. Not anywhere close, because all of my devices are going to be 1-stream device. So knowing what happens out there as far as the devices are concerned is of great help. In the office environment, you may have almost exclusively laptops, but then in stadiums, you're going to have almost exclusively smartphones. So that is kind of important to have that granularity when you are assigning the clients throughout the stadium or any other venue. Then it is user density. As we mentioned, in manufacturing it is low, in stadium is ultra dense, and then in hospital is dense, and in office generally it is medium. It is important to say that because when you have a lot of clients in one area, like in a stadium, there is absolutely no way that you can get away with a low number of APs. And yesterday we have heard an example. A gentleman mentioned that in one stadium there was like 1,700 APs, and that is essentially what happens when you have ultra-dense client density. Then the next one is what is the overhead of the technology. For 802.11 ABG, the throughput is about 50% of the listed maximum data rate, whereas for 802.11n and AC, it is much higher. It's about 80% listed maximum data rate. And this happens because they are more efficient in transmitting packets with a packet burst. Also, AP density, if they're closely spaced, then it is going to increase the interference, CCI, no matter what you do, especially if at 2.4 gigahertz. So then it becomes important to take into account what is happening in 3D. If you have very few channels and you have a high density of APs, then your CCI may really drive your throughput down. And then finally, available airtime. It is 50 to 80%. It's depending on the environment, whether you're in a stadium, in a campus, or in a warehouse. If you have one isolated AP, then your available airtime may go up to 100%, but that's almost never what you have out there. And then we're going to start talking about RF propagation granularity. So what I have here is a floor plan of a hotel where you have, in the middle is a swimming pool, and then what you have around are hotel rooms, and then to the left is the area where you have ballrooms, and finally there is the entrance area. So what you have is a really heterogeneous RF propagation. In the middle it is open space, and it is very dense where the hotel rooms are, and then in front of those ballrooms you have a semi-open area. So if you have RF planning tool that does ray tracing, then you really do not have to basically write down what you have, because ray tracing is going to take care of all this automatically. If you have COST 231, then you also don't have to identify those, because COST 231 is going to take into account the walls and open space as well. But if you happen to have a tool that has a one-slope propagation path loss equation, then you do have to identify those, because this will identify the slope of the propagation that is going to be used for calculation. And I'm mentioning this because if you are one of the lucky ones that does all the design on the laptop, then ray tracing is good. But if you have to do it quickly on your tablet, then you simply do not have enough, most likely you do not have enough computing power to go about doing things with ray tracing. And that's why you have to make do with some other kind of propagation and algorithm, and the slope may be something that you are using, and that's why it may be necessary for you to identify various RF different regions. The 3D propagation granularity is also very important. What you see here is a 3D vision of a hotel. The one in the middle is that pool area that I was telling you about. And then there are rooms that are around, and here is where the ballrooms are, and that semi-open area, and this is where the entrance is. So right there, what you're going to see is if you place your APs around, then there is going to be a good chance that there is going to be overlap of the signal in that middle area. And then if there is a good chance that in there you're going to have lots of signals coming from various levels. And that's why it is very important to make a 3D simulation of your signal to basically quantify what your CCI is and what your throughput per client is. So this is an example of what I was telling you about. This is what happens to your left if you are going to just confine yourself to doing the 2D simulations. Your CCI prediction in 2D may not look all that bad for 2.4 gigahertz. You see that red is where your CCI is equal to 3. And as you would expect, that happens in the middle of that, where that open area is. But that's just if you do simulation in 2D. If you go with 3D, then it gets really messy. You have CCI going to, I think, 10, up to 10. And that area is bad, but the areas around are not that much better either. So this is a real mess, and you know that 2.4 gigahertz is really crowded. And if you show what's happening in 3D, so that our propagation granularity. To recap what I was saying is, if you have multi-level structure, and especially if it is a heterogeneous structure like this one, where you have an opening in the middle, then you're well advised to do a 3D signal simulation to figure out what's going on with your core channel interference. Now we go on to user profile granularity. Well, most clients run a variety of applications over a longer period of time. When I say longer period of time, I'm talking about at least 1 hour. So, and that happens for most clients, which is to say I'm most likely not going to, if I'm going to be in the office, I'm most likely not going to be using just a single application over 1 hour. Or if you want to define over 8 hours, that's fine as well. So over 8 hours, if you're in the office, you're going to check your email, you're going to transfer some files, and you're going to do some browsing. You may answer a phone or call or two. So that's why it's important to define typical applications that a user may use in a certain venue. So what you need to do is you need to define a period of activity, and we advise to do that over a multiple of hours, at least 1 hour, and then find applications that are going to be likely to be used, and then quantify those applications. What I mean quantify by, when I say email, well, how many emails? Figure out what would be a typical size of an email. Then how many web page visits? What is the size of a typical web page that you are downloading? Then transfer of files, how many files? So this needs to be figured out. And then file size per unity of the measure, meaning to say if my average email is, let's say, 100 kilobytes, then if I am downloading 10 emails per hour, then that's the file size, 1 megabyte over 1 hour for emails, and so on and so forth. So all of this needs to be specified to let us know what user is really doing, and these specifications are often referred to as user profile. So different verticals have different user profiles, and what I mean by that is that the office environment may have different user profile than stadium and versus hospital. So different applications and different size of the files are being used in those verticals. Most venues have non-uniform client distribution, goes without saying. In a hotel, you have pretty much uniform distribution in rooms, but then what you have situation like in this ballroom, then you have a lot of people at one point in time. So hotel rooms, uniform, conference rooms, non-uniform. Now reception desk and breakfast area, they may go empty at some point in time during the day, and then they are all of a sudden very full. So they are examples of those hotspots that need to be addressed when you are doing the capacity calculation, capacity analysis. Those areas may also have a different usage pattern. What it means is that in a hotel room, a client may mostly run videos, SD or HD, and at the reception desk, it may be web browsing or voice over IP, and then in conference rooms, it may be emails and file transfers. Well, hopefully, nobody's going to be using voice over IP in a conference room when somebody else is presenting, right? So this obviously points out that within one venue, you may have different user patterns in different areas. And that may be for a different time of the day as well. So my next topic is, well, cellular and Wi-Fi. Well, a lot of venues have a mix of small cells or DAS and Wi-Fi and APs. Some cellular carriers have a habit of offloading their traffic to partner Wi-Fi providers. And the offloading mechanism, it may vary. It could be offload by application type. They may decide to offload all voice and offload of all the video and then just keep data on cellular. Or they may offload by signal KPI threshold, may decide that SNR is under a certain level, trigger certain threshold, then all the traffic from small cell or that particular branch of DAS is going to be transferred to nearby APs. Or it may be offload by cell load threshold, which means that there is, when traffic is high at an AP, when there is blocking, then they're going to start transferring the traffic to APs. But no matter what, that needs to be taken into account if you are given a task to design a Wi-Fi along something called a DAS or small cell network that already exists in a hotel or in a venue. Then you have to take into account that you are really going to be sharing those customers with cellular. Not in the sense that the customer is going to be connected at both at once, but some customers may stay on cellular, some customers may move to Wi-Fi. So that needs to be taken into account if you are aware that there is an indoor cellular network at the venue. So how do you do that? But you have to figure out the percentage of cellular and Wi-Fi customers throughout the venue, and also need to do that in each capacity zone. So what's going to happen in the near future? So you are probably aware of what's going on with something called LTE-U and LAA LTE. With the purpose of Qualcomm really insists on having inroads into 5 gigahertz. And, let's say that this is a controversial topic, but going forward, if this is approved, this spectrum sharing is approved, then it may affect the existing 5 gigahertz networks, existing Wi-Fi networks at 5 gigahertz. The coexistence mechanism, whatever it is, whether it's LTE-U or LAA, LTE, it may affect throughput and capacity on Wi-Fi. So if this happens, then in the future, the mentioning for both cellular and 8.11 may be a necessity in the near future. So this is not happening today, but a lot of things have happened in the recent year to point out that this is not impossible. So I'm just mentioning it as something that may go on going forward. So I want to show you an example on a hotel. Before I go there, I just want to let you know about that WiFi Mobile and IBWave Wi-Fi module that we have launched about a year ago, I think. And we just had the release 8 last week. And for that, one important thing that I wanted to point out is what it can do is it can capture cable routing. It has a full database of parts, 22,000 parts, can do 3D design and inclined surfaces. It has been tested in high-density venues for cellular networks, and it does have active and passive survey capabilities. And it can also run on a laptop or desktop, and it can run on a tablet. Tablet is the lighter version of it. It does have, as I said before, it has propagation is a little bit different. It is a one slow propagation on a tablet, whereas on a laptop you can do ray tracing, which we call fast ray tracing. So what I'm going to do now, I'm going to switch to the software, and this is the let me see. Okay. All right, so this is the hotel that we talked about. And in the map that we shared earlier, when I talked about the pool in the middle, and this is how it looks like. For the capacity planning, what we have to specify is the distribution of the customers per floor. We specify the user profile, which we call floor, and specify that most of the traffic happens at the Wi-Fi at 90%. We also have defined different zones. I'm going to point out where they are. And we also define a user profile with each zone and the breakdown between cellular and Wi-Fi. So this is the granularity that I was telling you about. Define each floor, and then within each floor define hotspots and separately define the number of clients in there. Also, the technology split is defined as well between 2.4 and 5 gigahertz. So all of those are specified here. And then on the floor plan, the hotspots are as this. This is the area where the pool is in the middle of the floor. And these are the ballrooms. And if you double click on that, you can basically specify the number of clients. Oops, but I have to, yeah. There it is. So if you double click on that, you can specify the number of clients and the breakdown between cellular and the Wi-Fi. So as what I was telling you about earlier is the breakdown of of the CCI when we have large number of IPs. This is at 5 gigahertz, and let me see if. And this is capacity. This is the co-channel interference, which is much worse at a 2.4. So this is the one that I showed you in the presentation. This is a 2.4, and this is in 5, which is actually much better. We only have 3 different CCIs. And if you want to take a look at how that looks in 3D, you can do that with this. So as you see, this is how it looks like at 2.4 in a 3D version, and all of those levels can be also observed with the different CCI. And for those Wi-Fi APs, we use generic ones, but you can go ahead and deploy any of the AirHive or Aruba, or they are all in the database. And what you can view is you can view the antenna patterns for every one of them. This one happens to be the omnidirectional antenna, and you can view from various angles the radiation pattern. When you are doing the capacity, you can go ahead and do at the requirements, you can specify the number of clients per each floor and the breakdown of Wi-Fi and cellular. And then in a market share, you can specify the breakdown between 5 gigahertz and 2.4, and also the breakdown between 1, 2, and 3 streams on the size, so 2 by 2 MIMO and 3 by 3 MIMO. For the usage profile, this is what I was telling you earlier. For each venue, we have defined a typical usage, and this is defined in increments of an hour. For some, it is per 1 hour for a cafeteria and a conference room. And then for some others, like office, we have 8 hours, because that's the workday. So you have to realize that what you have here is a size of files that are being transferred by a typical user over a certain period of time. So your throughput here is really a throughput that is defined over that period of time. So if I have transferred, 189 megabytes on Wi-Fi in cafeteria, that's done in an hour. So your throughput is really calculated based on transferring that file size over 1 hour. So that's what you need to take into account when you are doing that. And then finally, if we have a subscriber service there, you are defining the file size for each of those applications, typical applications. So that's what I was telling you. What is the size of your email? If it is 30 kilobits per second, then this is your unity, okay? So what is the usage in online gaming for 1 minute? Is a file size 1 megabyte. So when you do all those things, then you can define, when you click on all those different values, then there you can basically say, okay, I have, in cafeteria, I have downloaded 3 emails, and therefore my size for email files was 90 kilobytes. I did 6 minutes of online gaming while I was in cafeteria, so I spent 6 megabytes there, and so on and so forth. So that's how you go ahead and do and figure out the total size of how many of what you did over an hour in that location and what your throughput is over that period of time. Now, once you have done all this, it is important to also say when you are doing the analysis that there are venues where you don't really need to have multiple floors, simple venues, but if the venue is complex, then here basically you do not limit prediction by the number of floors. So when you do all this, then you do the analysis, capacity analysis, and I am not going to do it in real time because they have plenty of APs here, and then it takes maybe about 10 minutes to do that. So I'm going to show you the results. I'm not sure why I'm not seeing the... Okay. So basically, in the capacity, what you are seeing here is it's going to tell you a couple of things. For first, airtime utilization is given per pixel. This is the first percentage that you see, give you 2.17%. So in that pixel, airtime utilization is that much. In the whole venue, it is 22.42%. Airtime limit for this venue was 80%. And this is what you can actually set up in this location here. This is where you do airtime utilization. So for this venue, you say it's 80%. So basically it says airtime limit yours 80% and you have used up 22.42%, so you are well below the limit. Your traffic, which is the number of clients in that particular location is 3.79, and it is 22.96 throughout the venue. And equipment limit, which can be assigned per each of those APs, is 64. So you do not have the you have not hit the equipment limit. Your average data rate per client calculated to be 650 kilobits per second, and your target throughput was much less than that, 182. So how did you get your target throughput? If you recall, that's what I was telling you about, is the definition that you have set up right here for usage profile. So you basically say that for each of those you have a different one. For the hotel, your throughput per client is 182 kilobits per second, and you had a much higher throughput, which means that you are okay. You can add more clients to this venue. And what's going to be of interest as well for you is going to be the average downlink throughput. So there, basically, you have a different throughput depending on where you are in the venue, depending on the density of the users. As you see, it goes from very high, which is, I think right now is 43.24 megabits per second in this area, and then drops down as the number of clients increases. For example, in the pool area, it is only 289 kilobits per second. And in this area where you don't really have that many users, it goes up to 43 megabits per second. So you can do that in both 5 and 2.4 gigahertz. And needless to say, I had much better results at 5 gigahertz because 80% of my customers have been defined on 2.4 gigahertz network. So I have a fewer clients at 5, and I have a much better CCI distribution at 5. So needless to say, my 5 gigahertz band 802.11 network is working much, much better than my 2.4. So those are the things that would be of interest. Co-channel interference capacity calculation, where you can see your airtime utilization and average average data rate, average throughput per client, basically. So so anyway, all of those can be presented in 3D as well, and with that, I pretty much am open to questions. This kind of wraps up my presentation. So I'm at this
Thank
point
you.
Open to
Questions for Vladan?
Thanks for an interesting thing, but how do you import maps into it? Is it CAD maps or?
You can do, you can do CAD maps, you can do regular JPEGs, and then you can write walls if you want to, manually. Or if you are going to do the one slope path loss, which we also have an option, then you just do a JPEG, but you have to basically, on a JPEG, you have to mark the RF density. And we have several options like OpenRF, which would be this area where the pool is, where we have open area, then semi-open, which is basically this area here at the ballroom, and dense area, which is right here. So you do that if you have a JPEG and do not want to draw the walls. It is the least accurate, but it is the one that we have actually put out because we figured out that we cannot have ray tracing in tablets. Tablets simply do not have firepower enough to do ray tracing. So that's what we have. And in our tool, because this is a laptop version, you can go on and basically go to project properties. And then there, it gives you the option of which propagation model you want to choose. Fast ray tracing or COS231 or variable path loss exponent or VPLE. So you can choose any three of them. Fast ray tracing is what I would suggest if you have a laptop, and the other two if you have a tablet. Now, really nice thing about all this, which I forgot to say up in this point, is that you can actually collaborate between a field technician that has a tablet and your engineer that sits maybe 1,000 kilometers away in an office. So what you do that is, if you go out there with the tablet, you can go off and do RF survey and have a floor plan and then take a picture of, where the telecom closet is, everything. And then you can then, put basically make comments and everything, and then you can save it to the cloud. You can even do a preliminary design using your VPLE or COS231. And then you upload on the cloud, and your engineer, your RF engineer, can actually download that from the cloud, open on his desktop, and then rerun this analysis using fast ray tracing, do validation of the RF propagation analysis. So that way you have instantaneous collaboration between field technicians and your RF planners, your RF engineers, which is a really nice thing about this. Mm-hmm. Right. Yeah. You can actually collect the data and right. So this is a survey option where you can actually do the survey data, and you can do either active or passive survey data. You can set up your server here, and then you can do the transfer analysis, file transfer analysis to collect the throughput data, or you can do a passive survey if you want to as well. And then what's going to happen is that you will be able to collect the data in the area where you want to. It's going to look like this. Just see. So basically, your data, this is your survey data that you have collected throughout. So that's how it looks like. But yes, you can do active and passive survey and using this tool, and you can do it on a tablet as well.
Yeah, I have a question about that too. I heard from Twitter that if you do a survey, it is possible to validate the building model if you have a building model. Is that true?
Okay, so are you talking about RF calibration or?
Yeah, you may call it this way.
Okay, yes. Yes, we do have we do have RF calibration. Basically what you would do is you would collect the data, CW data, throughout the building, and then you can use that to calibrate your RF fast ray tracing propagation model. And what's going to do is basically what it does, it calibrates not only the propagation constants and such, it calibrates also the path loss through walls, through barriers, through obstacles, right?
That means it calibrates the loss value
Yes.
of my wall element.
Yes, that is correct, yes.
So then it is true what Twitter said?
Yeah, that is true, yes.
Okay.
And then, yes.
A second question, a sales question, of course. How is it licensed, the tablet version and the laptop version?
That's when I say I'm going to take your business card and introduce you to my sales force. I'm a technical guy. I'm a research director at IBWave.
No problem. We will do that.
I appreciate your question, but I don't really know.